Uh, I'll discuss illustration 34th in functions. Now see, there is a misprinting in this question, so let me write the correct question first. Fx is square root of x square minus greatest integer x whole square. Now what we are supposed to do is we are supposed to find domain of fx. Now for domain of fx, quantity inside square root cannot be negative as well as cannot be negative, right? It should be non-negative, 0 or positive. So x square minus greatest integer x whole square should be greater than or equal to 0, right? Now to find the values of x, we satisfy this inequality. We'll draw graph of greatest integer of x square first. So let's draw graph of greatest integer of x whole square. To draw this graph, we'll draw graph of y equals to x square parabola and then replace x by greatest integer x. Replacing x by greatest integer x means we need to, so there's some steps which you would have gone through in theory, that let me just quickly go through those steps. Suppose this is graph of y equals to fx and we replace x by greatest integer x. This is fx and we need to plot f of greatest integer x. Now what we do is we plot integer lines, vertical lines at integer values. So this is x equal to 0 line, this is x equal to 1 line, 2 line, goes on. And once we have these vertical lines, we mark points of intersection between these vertical lines and graph of y equal to fx function, right? Now from every point of intersection, we just draw a horizontal step of 1 unit length, like this, open towards right. A horizontal step of 1 unit length, open towards right, open towards right, open towards right, like this. So this is how we draw graph of f of greatest integer x from graph of fx. Again I repeat the steps. We draw vertical lines at integer values like x equal to 0, x equal to 1, x equals to 2, goes on. And then we mark points of intersection between these vertical lines and graph of fx. And from every point of intersection, we drag a horizontal step of 1 unit length towards right. And we have to make sure towards right it is open. So this point is not included, right? Now let's draw graph of greatest integer of x squared. So we can just remove this. Parabola x square, right? Now we draw integer lines, x equal to 0 line, x equal to 1 line, 2 line, minus 1 line, goes on. Now we mark points of intersection. Sorry, this one. From every point of intersection we draw a horizontal step of 1 unit, like this, like this, like this, right? Now we have like both the graphs here, both the graphs present here. Graph of x square is a black graph and graph of greatest integer of x square. Now we need to find those values of x which satisfy this inequality, or we can say we need to find those values of x where graph of x square should be above graph of this. We want this to be more than this. X square should be more than greatest integer of x square. right? So more than means like for those values of x where x square parabola is above this greatest integer graph. And if we look at, if we see towards right of y-axis, we can see parabola is above. That's what we want. Parabola is above horizontal steps. Black graph is above red graph, right? So for all x greater than 0, 1 equal to 0, parabola x square is greater than greatest integer of x square, right? So all positive, non all positive values satisfy this, including 0, non-negative. Now if you just see the left half, x less than 0, let's see what are the values that satisfy in left half, satisfy this inequality in left half. In left half, you can see, just draw one more line. Parabola is below the greatest integer graph, the red graph. Black graph is below the red graph. We want it to be either equal, we want x square to be, parabola to be above, or they meet. So you can see, we just in left half will just take only the integer points. For example, -1, we will include -1 in the solution set, because at -1 x square is equal to greatest integer of x square, because they are meeting, there is a point of intersection. So it means this is equal to this equal to this means 0, and we have to include those points where this expression is 0. So for x less than 0, we include all integer points. X belongs to all integer points, -1, -2, -3, goes on. Or we can say x belongs to integer minus, right? And we can combine the two. We can combine first and second. So domain is x belongs to 0 to infinity, all non-negative values, and then union minus n, where n is natural number, positive.